Friends, whoever have seen my earlier video called Learn the CBSE Physics 12 with a complete understanding in 5 months and score the good marks. In that video, I had promised that I will take you at another level of understanding of physics by giving you a small video clip on the Doppler effect explained for CBSE 11th and 12th physics. Now, why I have taken the Doppler effect as the topic of discussion because it is common in the 11th standard as well as in the 12th standard. Therefore, I have taken this for the discussion. Now, my contention here is the point which I want to make is that when these topics are taught in the book or these particular Doppler effects is taught in the book of 11th syllabus, the explanation came something like this. It's a bit weird to understand. And the diagram which is shown here doesn't make much difference. Okay, and much sense to us. And therefore, we find our difficulty level too much for the subject. We find it difficult to understand the subject, and there really the problem starts. So, I want to make a case that if the physics is taught in a proper way with a complete understanding is very interesting first thing, very easy to understand second thing, and then it is very easy to score the good marks and we can do accomplish everything in a stipulated time. The same Doppler effect appears in the 12th standard although also, and that is in chapter called light. Here also it comes in some paragraphs like this on numericals with no diagrams, and therefore it makes more difficult to understand this particular topic. What I am trying to do is I am to make my case by explaining you the Doppler effect, okay, in a very simple way and with some animations also. Maybe that animation will help you to understand the Doppler effect well. Now here you can see that there is aeroplane that is moving from soldier to this. Now this particular aeroplane, when is moving from the observer from towards to away, there is a pattern and change in the pattern of the sound. When it is going towards the soldier, when the plane was approaching to the soldier, the sound was getting more shriller, the pitch was high. And as the plane was going away from the soldier, the sound was waning, and therefore the shrilling effect was also getting less and less. So this kind of the pattern that arises or happens in the physical phenomena, it is known as the Doppler effect of the sound. The question is very interesting to see. It happens. It happens now every day. Every time we travel around, physics is everywhere. It's not confined only to the books. Why it happens? Let me understand a bit. Now here we see. I will just recall you something which we have learned before. That we know the velocity of the sound is equal to the wavelength. What is the wavelength? It's shown here in the pattern that one first and one fifth. Okay, that makes a wave, and this particular is called a wavelength. Time required for one wavelength is called time period, and in 1 second number of cycles that will make is called a frequency. So we have a formula: velocity of sound is equal to wavelength of sound upon the time, or we can say velocity of sound is equal to wavelength of sound into frequency. This we have learned in before. Now here there is a source of sound. There are two observers, one onto this side, one onto this side, and both the observers will hear that particular sound with the same level of frequency, pitch, and loudness. There will not be any difference to it because the source is stationary and the waves are moving radially outward, and therefore the sound approaching here and approaching here will be the same frequency and same wave. So what happens basically? When this sound, okay, if lambda is the wavelength, I already explained you, V will be equal to lambda by T or V is equal to lambda into Fs. This particular source will now start moving towards the observer on the right hand side. I would say this is the soldier, particularly in our case, and the aeroplane was approaching to the soldier. See what happens. The pattern of the wavelets will change, and the change in pattern is what? Here the wavelength of the frequency is reduced. Here the wavelength of the frequency has increased. You understand? Here the wavelength of frequency is decreased. Here the frequency has increased. And this particular change in the frequency is caused because of what? Because along with the velocity of the sound, the source also has got its own velocity. So for an observer at this end, these two velocities are added. V plus Vs. V is the velocity of the sound and Vs is the velocity of the source. They both got added. So for this person, the wavelength will become more, which can be given by the formula lambda dash is equal to V plus Vs into T, that V is the sound, Vs is the source plus T into T. Now what happens for observer number 2, lambda double dash, the frequency is increased, the wavelength is reduced. Now this can be written by the mathematical formula that lambda double dash is equal to V minus Vs. The relative velocity for the observer number 2 is equal to V minus Vs, because the source velocity will get subtracted and into T. Okay. So you can see, because of this, okay, because of this, what happens? The frequency increases and the wavelength increases. Now if you analyze this, it will be very clear that how the mathematical pattern arise out of the observations and discussions. And once you understand this, it will become very easy for you to solve the numericals, derive the formulas or whatnot, whatever you say, that can be done very easily by particularly understanding this particular wave pattern and the formula arising out of it. Now let us go to the Doppler effect explained in the 12th chapter, 12th physics. This Doppler effect arises in the 12th physics in the chapter called light. Astronomical objects which are in the, like galaxies or meteors or any other thing, or the stars, planets, whatever they are at a distant level. All of them, they emit the light. We know on that. And while they are emitting the light, you can obtain the spectrum as we are getting the spectrum obtained from the sunlight or any other light medium object. You can get the spectrum of this. But when the spectrum of these objects which are taken of the reflected light from the sources, they give exactly not the same pattern as it is expected, but there is a relative shift in the kind of the pattern what they give. The thing I will try to explain it with you is that these celestial objects, they are not stationary, and therefore they are either moving towards you or they are moving away from you. So when somebody is moving away from you, we have learned in the last chapter, the wavelength increases when the object is moving away and the wavelength decreases when the object is approaching to you. So if I take the spectrum of the light, the red wave is more having a more wavelength and the blue length is relatively having the shortest wavelength. So if any object is moving away, it will give a red wavelength pattern because the wavelength increases. And if any object is shifting towards you, the wavelength will decrease and it will give a blue shift, or the blue type of the ray will approach to you. And this may not be what you call physically, sensible to you, but when you take the patterns of this, definitely they will show you the difference in the pattern of the shape. Now how that difference in the pattern of the shape they arise and how it is compared with the standard laboratory model, that we will get some explanation. Okay, so here we can see that the different line patterns have a different wavelengths. The violet line has got the wavelength of 400 nanometer and the red has got 700 nanometer. So you can see this is a hydrogen spectrum, the different light patterns they are given at the top. Now different planets and different celestial objects have different atmosphere or no atmosphere or different numerical minerals in their uh, surfaces. So the spectrum of light can tell us what elements are in the stars, in the galaxies, because each element has a unique energy levels and therefore emits or absorbs light at a particular wavelength. These characteristic wavelengths are called the spectrum lines because the lines shown up as discrete frequencies in the spectrum of light from the star. So we can get a different patterns of the lights. It may be of the sodium, it may be of the hydrogen, it may be of the nitrogen. The kind of the atmosphere that particular planet has got, that kind of the pattern will arise and that will be shown in the spectrum. Now that particular spectrum will be now compared with the standard spectrum. Say that the sodium spectrum that is being observed from a celestial object, it will be compared with the laboratory spectrum of the sodium, and there you will see this spectrum and this spectrum either they are differing in this manner. If you observe a red shift in the spectrum pattern, then you will say the source or object, celestial object is going away. If a blue shift is shown in the spectrum, you will say that celestial object is moving towards. Having said this, if these lines are observed to be shifted from the usual wavelength to short wavelength, then the light from the galaxy is said to be in the blue shift. I already explained to you. This complete small presentation will give an idea that if the physics is understood in a better way, definitely it is lot more interesting subject. It can give you a good marks. Friends, before I sign off, I want to tell you again one thing. My online classes for VBSC 12th standard already started. I don't take more than 5 students per batch. My contact mail is bapprapradeep18@gmail.com. I still again urge you see by another video in which I have explained that how to study for the 12th standard in 5 months. Okay, with this I am signing off with you on this particular video. Thank you. Thanks a lot.